Alright, let's continue with these practice problems. Number 3, probably a little bit more straightforward, just a simpler molecule than some of the others, although there's definitely going to be a fair amount of stereochemistry to deal with. So I think it should be fairly clear that our longest chain, our only chain, just goes straight down the center. Now, which way do we number this? We can do it in both directions. So we can see that it is a heptane, or in this case a heptene. And once we number it in both directions, we can see that with the green numbers, our alkene starts at 3, whereas with our red numbers, the only alkene starts at 4. So therefore, we know we're going to number it from left to right. And that means our root here is going to be heptene, and specifically 3-heptene, because that's where the alkene is. All right, let's erase some of those red numbers since we know we don't need them now. Again, we could make a list of substituents here as well, but with only 4 of them, it's actually a lot easier. We have the bromine, the chlorine, the methyl, and the iodine. So we have 5 bromo, 6 chloro, 1 iodo, 2 methyl. And so from here, we just need our stereochemistry. And that's going to show up, we have a chiral center at 2, an alkene at 3, chiral center at 5, and a chiral center at 6. So let's erase all of this so we can see it better. If we look at the alkene's probably pretty easy here. The 2 hydrogens that are not drawn in, which are definitely the lower priority groups, are on opposite sides, so we know here the alkene has to be E. At carbon 2, we have the hydrogen that's not drawn in is pointing back. On the left, we have a carbon attached to an iodine. Because of the iodine, that gets higher priority than the carbon that's attached to other carbons, which gets higher priority than the methyl. Arrow goes counterclockwise, we have 2s. Over at carbon 5, again, the hydrogen that's not drawn in is pointing back, so we don't have to adjust for that at the end. But the bromine is highest priority. Then we have a carbon to the right that has a chlorine versus a carbon on the left that's just bonded to other carbons. The chlorine is higher priority than the other carbons, and so our arrow goes counterclockwise, and we have 5s. Before we look at 6, let me erase those so we can see it better. So at carbon 6, we're going to have to flip whatever we get because our lowest priority group, the hydrogen, points forward. But chlorine we know is highest priority. That's higher priority than carbon here or carbon here. On the left here, we have a carbon bonded to a bunch of other stuff, including a bromine. That's going to be higher priority than a methyl. Arrow goes counterclockwise. We have to take the opposite because the lowest priority group points forward, and so we have 6R. All right, let's move over to this cyclic compound. So part of this is going to be easy. We know this is going to be a cyclohexane, 6-membered ring, and we know it has 2 alkenes, so it's going to be cyclohexadiene. But where do we number this one? And that's actually the really tough piece in this question. The substituents are relatively easy. We've got bromine, a chlorine, and 3 methyls, and we've got 2 chiral centers here and here. We don't have to label E and Z in this question. The reason for that is that it's only a 6-membered ring. And so you can only have one way that alkenes can align in a 6-membered ring. But what are our choices for numbering? Well, we know we're going to have to start at one of the alkenes. And so I'm going to give us our possibilities. So we could start at the alkene on the left and go that way. Hopefully you don't put 2 numbers on the same carbon like I just did. But if we start at this carbon, the one I just started at, we can't go the other way. And that's because our numbering has to sequentially go through both carbons of the alkene. Now we could also start down here and go the opposite way. Alright, now there's a couple more possibilities. I'm going to run out of room on that drawing though, so I'm just going to redraw the molecule over here. Because I can also start at the alkene on the right. And I've got, again, 2 possibilities for that. The one that I've drawn in first, and then this second possibility that I'll put in the middle. Now notice all 4 of those examples will give us 1 and 4 for the alkenes. So how do we break that tie? Well, at that point, we go back to what we would normally do with substituents. And so immediately we can rule out one possibility, which is the sort of yellowish brown numbers. Why is that? Well, the purple, red, and green numbers all have a substituent at 1. But these numbers that start here on the inside don't have the first substituent until carbon 2. So we can rule those out. Right, so the remaining, the purple, red, and green, all have substituents on carbon 1. What about carbon 2? Well, the purple numbers don't, but both the red and green numbers do. So that means we can actually rule out both sets of numbers on that molecule. So back over here, if we go to the 3rd carbon, each one has a substituent. At the 4th carbon, though, the green numbers have a substituent, the red numbers don't. And so that's finally going to allow us to break our tie here. So let's get rid of these red numbers, and we now know our green numbers are correct. So as part of our name, we now know our alkenes start at 1 and 4. We can get our substituents in now. 3-bromo, 1-chloro, 2,4,6-trimethyl. What's left? We need R and S, and we're going to need those at 3 and 6. So 3 is the carbon with the bromine. Clearly the bromine is higher priority than the carbons. Now the carbon over here is actually pretty much identical to this carbon. So we have to go down one more. But this carbon here is bonded to a chlorine, whereas this one has a hydrogen. So we'll go this way, which is counterclockwise. But because our lowest priority, the hydrogen, points forward, we have to take the opposite, which is R. Finally, to finish this one, we go down here to carbon 6. Again, because this hydrogen is pointed forward, we need to take the opposite. First priority here, second over here, and third to the methyl. Arrow goes clockwise, which is R, but again, we have to take the opposite, so this is 6S. All right, one final problem here. Again, I think we have a relatively easy longest chain to spot. Go straight down the middle. And again, having an alkene at one end tells us very clearly we need to number it in this direction. So this one's a little bit more complicated. So again, I'm going to make a list here of what this molecule contains. So 1 has an alkene. We will not need to do E or Z for it. 2 has nothing. 3 has a methyl. 4 has an alkene. And 4 we will also need to do EZ. 5 has an isopropyl. 6 has a methyl. And 6 is also chiral. 7 has an alkene. We will also need to do EZ there. 8 has nothing. 9 has a bromine. And 9 also has an iodine. Finally, carbon 9 is also chiral. And I did forget to label, but carbon 3 is chiral as well. So a lot going on in this question. So I'm just going to scroll down a little bit so I can start dealing with the name. So we know we're going to need 3, 4, 6, 7, 9. Then we can start putting in our substituents. 9 bromo, 9 iodo, 5 isopropyl, we've got the 2 methyls at 3 and 6, and the parent name, Nona 147 triene. So all that remains is for us to determine our stereochemistry. And let's start at carbon 3. We have a methyl, which is going to be lower priority than either of these alkenes. The alkene on the right is higher priority than the one on the left. This goes clockwise. The low priority substituent, the hydrogen, is already pointed back, so this is 3R. All right, for the alkene at carbon 4, we have a hydrogen on the one side, so that's lower priority than the carbon group. On the other side, we have a carbon that's bonded to two carbons, carbon bonded to two carbons. So we have to go further. We have methyls, one of which is the same, but the other is an alkene, which is higher priority than the methyls. So 1, 2, higher priority groups are on opposite sides. So this is 4E. Our stereocenter at carbon 6 has the low priority substituent of the hydrogen pointed back. The methyl is going to be lower priority than the alkenes. And on the right, we have a carbon with a double bond to another carbon. But on the left, that carbon, in addition to having an alkene, also has an isopropyl group. That makes it higher priority. We have 6R. Our other alkene, this one here, we can see the higher priority groups are opposite. We have 7E. And finally, our last stereocenter, iodine is higher priority than bromine, is higher priority than carbon, which is, of course, higher priority than hydrogen. Now, this one is a more awkward example to look at, because the hydrogen, the lowest priority, it's not pointed back, so we are going to have to make an adjustment. But it's also not pointed forward. Because it's not pointed forward, this is a molecule that we're going to have to rotate. And so it may benefit you to get your model kit out. And when you do that, and you rearrange this so the hydrogen points back, we should see that this is 9R.